Before we get started solving any of these problems, I want to mention that I am assuming you have some familiarity with factoring out the greatest common factor and factoring in general. If you need some review on those topics specifically, I have a number of videos already prepared, and I go into a fair amount of detail explaining rules for exponents, rules for factoring, review of factoring. Well, this would be factoring out the greatest common factor, which we just usually say the GCF, and then factoring in general. But this is with leading coefficient of 1, or a lot of times I'll just say, oh, there's nothing in front. And then for examples of maybe some of the more complicated ones, if you refer to any of the videos that I have posted for 11.4, okay, most of these show factor by grouping as well as what I refer to as the box method. Okay, so you may want to refer to those videos if I'm going at a pace that's a little too fast for you here. Alright, so we'll pick up with number 2. And let me zoom in a little bit and get to work here. That should get us started. Alright, so looking at the 56, the 6, and the 21, a lot of times for the greatest common factor, the GCF, you just look at the numbers and think about it. But if nothing occurs to you, then you can use the prime factorization of each number. And very briefly, the GCF of, let's say, 4 and 12, the greatest common factor, the biggest number that will go into 4 that will also go into 12 is 4. So for these two, the GCF is 4. Sometimes things get a little trickier, but sometimes you can just see it right there. The GCF of, let's say, 6 and 20 is going to be 2. I can get a 2 into a 6. When I say goes into, it has to go in evenly, and 2 would go into 20. But 6 won't go into 20, 3 won't go into 20, so 2 is the GCF. Sometimes they'll throw you a little curveball, as we're about to see here. Looking at 56, 6, and 21, if nothing occurs to you, go ahead and list the prime factorization of each term. So for 56, just have to slide this over a little. The prime factorization, let's see, 2 times 28, and then 28, you might think of 4 times 7, and 4 is 2 times 2. I can see I'm moving off my page, so we'll have to back out a little bit here. Alrighty, and one more. Alright, so we just did the prime factorization of 56, and I'll bring this 2 down, and I'll bring the 7 down. All these numbers, if you multiply 2 times 2 times 2 times 7, you'll get 56. Alright, let's look at the 6. Alright, 6 won't take very long. It's just going to be 2 times 3, so I'm going to kind of bring them way down here. 2 times 3, that takes care of the 6. And then 21, again, that won't take very many steps. I'm just bringing it way down here. That's 3 times 7. Okay, so I have the prime factorization of each one. For GCF, get out a different color here. For GCF, focus on common. It has to be in common to each one. You have a 2 here, a 2 here, but there's no 2's. You have a 7 here and a 7 here, but there's no other 7's. So in fact, the greatest common factor is just a 1. Okay, usually you can find something, but in this case, you can't. So GCF of these 3 numbers is a 1. let's take a look at another situation. Number 3 here. And I think we can zoom back in. And let's see. Here there's no leading coefficients, just variables with exponents. All right. So to solve these, excuse me a second here. You're basically going to focus on each exponent for the greatest common factor. Let's say looking at our first one. And remember, greatest common factor, you're looking for the largest factor that you can get out of each term. I could certainly get an x10 out of here, but I couldn't get x10 out of here, nor here, nor here. Okay, so looking at just the x values, this is x to the first power. So that's the largest x I'm going to be able to get out of, if I look at all 4 terms here, is x to the first power. As far as the y's, we've got y to the 6th, the 10th, the 9th, and the 10th. So y to the 6th. Alright, so x, it's just going to be x to the first power, or you could just have x. And then y is going to be y to the 6th. Okay, and here they're just saying to find the GCF. They're not asking you to factor it out. So there's the GCF for number 3. Let's see, number 4. Looking at these. Looking at the 14 and the 56, it might not occur to you that the GCF is 14. So if it doesn't jump off the page at you, just go ahead and look at your 14. The prime factorization is 2 times 7. Look at your 56. The prime factorization I don't know what might occur to you. As long as something times something is 56, you're on the right track. I'll notice that 7 times 8 is 56. For the 8 I have to keep going. That's 2 times 4, and 4 I have to keep going. 2 times 2. Alright, and I like to have these all line up. Bring down my 7. Okay, so here's the prime factorization of 56. Here's the prime factorization of 14. So common factors. I have a 7 here and a 7 here. Okay, I have a 2 here and a 2 here. So I'll be multiplying. I don't have any more factors, so there's certainly nothing else that it would match with. So 7 times 2 is 14. 14 is going to be the greatest common factor of 14 and 56. So the GCF for the list is 14, and then regarding the m's, I can get m to the 4th out of here. I can get m to the 4th out of here. So 14m to the 4th is the greatest common factor. Alright, we'll take a look at number 5 now. And this is more like the sort of situation that's going to come up. You're going to have to factor out the GCF from the polynomial. Okay, and I spoke extensively on another video about what it means to factor it out. But basically, when we say factor out, we're saying divide it out in such a way that you could put it back. So the GCF is 7, and if I'm going to divide out a 7, I have to show a way that I'm willing to put it back. Because in mathematics, you're not allowed to change the value of what you're given. You are allowed to change the way it looks. So if I have 7x divided by 7, I would just be left with x. If I have negative 7 divided by 7, I would just be left with a negative 1. So I factored out the GCF of 7 from these two terms. And notice if you send it back in, you can get right back where you started. Okay. We'll take a look at number 8. That's a little more complicated. Maybe I'll get another sheet on here. Okay, first you have to find the GCF and then you have to factor it out. So looking at each term, I think I could zoom in a little bit on this. There we go. All right, looking at the 12, the 32, the 12, I can get a 4 out of there, a 4 out of there, and a 4 out of there. So 4 is going to be the number. And as far as my variables, x squared is the highest exponent for x's that I can get, whoops, sorry there, out of each term. And then for y's, a y to the third. And if I factor 4x squared y to the third out of my first term, which means divide it out, I'll be left with 3x to the sixth, and it turns out y to the sixth. Okay. For 32, I'll be left with 8. X squared divides into x squared one time, so you're not going to see that. It just turns into a 1. And y to the third, let me see. If I divide y to the seventh by y to the third, I'll have y to the fourth. And then for our last term, 12 divided by 4 is 3. This will leave x to the fourth. And y to the third, this y to the third divided by y to the third is 1, so there's nothing left. Again, if you need a more detailed explanation, you'll have to refer to the other YouTube video where I cover, let me put that up here again, okay? Factoring, review GCF, factoring out greatest common factor. It's a very detailed explanation of how this occurs. And let's see, we will take a look at number 9. The greatest common factor on number 9 is, as it turns out, the only common factor, but it might not be something you're used to noticing. You have in parentheses y plus 2, and over here you have in parentheses y plus 2. That is your greatest common factor. So when you factor something out, the practice is you put it in front. All right. So here's y plus 2. And when I factor that out from the first term, from right here, I'm left with x. Factored out from the second term, I'm left with a positive 14. So this is the answer, and you factored out the GCF. Let's see, we'll also take a look at number 12. On this one, they're only asking us to, let me bring the directions, factor a negative 1. Okay, for factor a negative 1 from the polynomial. So that means I'm going to divide each term by a negative 1 in such a way that shows I'm willing to put it back. So I have negative 1 outside the parentheses. And again, this is just what keeps it balanced. If I change the appearance of the number, I have to basically show how I did that, or of the polynomial. I have to show how I changed it so someone could put it back exactly the way it was. All right. So positive 6a divided by a negative 1 is negative 6a. Negative b divided by a negative 1 is positive b. And positive 7 divided by a negative 1 is negative 7. So notice what really happened is each of these signs changed. And we will take a look at number 16, and that'll be the last one we do on this video. Here they've asked us, let me show you, factor the 4-term polynomial by grouping. So we'll go ahead and use the grouping on this. The word grouping, you really want that to stand out. That means we're going to group together the first 2 terms, and we're going to group together the last 2. So for the first 2, I'll group together these. And now you look for the GCF within here. It's going to be 5x. So make sure this is still on the paper. 5x is what I can factor out from my first 2 terms. So if I factor a 5x out of 20x squared, I'll be left with 4x. If I factor a 5x out of negative 25xy, I'll be left with a negative 5y. And notice if I send it back in to each term, I'll get right back where I started. Okay, now you look over at the next 2 terms, and that's right here, and you look for the GCF. With the 12 and a 15, I can get a 3 out of each. Y to the first power is the most in terms of variables that I can get out. So 3y, and it's going to be a positive 3y. I'm going to factor that out of each of these 2 terms. And that's going to leave me with 12xy divided by 3y would leave us with 4x. Notice it's looking like this one over here. Negative 15y squared divided by a 3y is negative 5y. And look at that. What I have in parentheses is identical. That is now my greatest common factor. So I'm going to factor out this 4x minus 5y from each term. Okay? So 4x minus 5y is going to get factored out. And when I factor that out of this first term, I'm left with 5x. When I factor 4x minus 5y out of this second term, I'm left with 3y. That'll take care of this one.